You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Podcast, episode 32. And in today's episode, in our news segment, we're going to chat about this potential jetpack person flying at 6,000 feet above LA, which is seemingly unconfirmed and also terrifying. And also, we're going to talk a little bit about Boeing potentially selling one of their HQs and considering some mobile options. So as you know, as everyone is rethinking, what office life looks like. In our engineering segment, we are going to talk a lot about birds. There's an interesting study on bird flight with the barn owl, also the Airbus Albatross, which has actually segmented wings, if that's the right term for it, but they sort of flap. So really interesting demonstrator technology there. And then lastly, in our electric tech segment, we're going to chat about drones being used at the airport, which is a pretty cool idea. And then the Ampaire, so their EEL aircraft has made some pretty impressive long-haul flights. Well, maybe not long haul, but some pretty impressive distance flights recently, as in what they call the most maybe commercially relevant electric aircraft at the moment. So, Alan, let's start with, what is the deal with this jetpack?
Yeah, I don't know. Isn't it crazy that we've had now two sightings from airplanes from multiple aircraft coming into LAX where they see what looks to or appears to be a guy in a jetpack? Because the feedback to the control towers and the ground crews are, it looks like a guy in a jetpack. So the pilot's eyes, think about pilots as they usually have pretty good eyes. That's one of the criteria to fly an airplane. Mm-hmm. So I would say that they're probably telling you the truth, that they're actually seeing this guy in a jetpack. Now, in this mobile phone dominated world where we're taking video of all kinds of things, it's weird that nobody has posted any video, or I haven't seen any video on TikTok, Facebook, Twitter, Snapchat. There's just no video of this thing occurring, and it seems like if it's some sort of prank, that there would be a ton of video online about it that would get picked up somewhere. But we don't have that either. So there's a lot of curiosity about it, because if it ever got to a situation where it ran into an airplane, that result would not be good. And if it is a real person, and there's been conjecture that it's a dummy attached to a jetpack or some sort of, I've even heard some discussion about being a helium-filled thing that just floats around. Maybe it is, maybe it isn't, who knows? But I just don't want to be playing around airports. That's one of the sort of basic fundamental rules around airports, is don't put things in the air where an airplane can run into them. Because you're risking a lot of people's lives for some nonsense that you want to go pull off. But yeah, do you think it's a real jetpack, Dan?
Well, in reading this article from NBC News, so David Mayman is the CEO of Jetpack Aviation in LA, and he said, it's kind of funny, that they have 5 jetpacks. They're all under lock and key. Only he and his chief engineer have those keys. So they're like, no one's taking these out, under our nose. And he also said, he had a lot of really good reasons that this is probably not A, one of his packs for sure, but B, so he said basically their model holds 12 gallons of fuel, which is about 10 minutes worth of flight time. And it would take about 7 minutes to climb to 6,000 feet, which is where the recent sighting was. Right. So he said to get up there and come back down, he said it's pretty unlikely, you probably just wouldn't make it fuel-wise. And then when it does come down, it uses a large parachute, essentially. So he said these things are so loud, they're super interesting, obviously. They come down with a parachute. He's like, why wouldn't, if this was actually happening, someone would have taken a cell phone video. Just see this going on. There would be evidence that someone's doing this, but nothing's surfaced so far. So he thinks it's just a drone. Some kid just made some crazy drone and I don't know, maybe attached a dummy to it. Who knows? But well, it does seem pretty implausible the way he describes it.
Well, okay, so let's get back to the real interesting part of this, which is the David Blaine balloon stunt. Did you see that David Blaine magician
I watched some
guy?
of the. I think he's an interesting dude. I watched some of it, but it was like a 3 hour long like YouTube video.
Yes, it
So
was.
I watched a little bit of it. Yeah.
Well, in
But
our
I think I
secluded.
skimmed. But I think I skimmed enough where I didn't like get the point. So the little that I watched, I like screwed it up for myself. I should have skimmed more effectively.
Well,
But
do you think that this may be a follow-on, a copycat to what Blaine was doing? Because he basically took a whole bunch of helium balloons and tied it onto a lawn chair. Isn't that what happened? Or he was holding on to them. He was physically holding on to them for a long time.
well, he was holding on to it, but it clearly like that wasn't what was keeping him attached to it, right? He was just
Right.
holding on there for stability.
Your life.
Yeah, because I was looking at that, I'm like, there's no way you're only suspended by your forearms right now. That
No.
just wouldn't be realistic. But
No, no, no.
but yeah, so I mean, I wouldn't. You never know. Something could surface that this is actually like Batman or Iron Man or something. David Blaine, who's probably the closest to being probably Batman in
Well,
our midst.
I think one of the things, yeah, that's true. But is one of the Blaine problems, or what they were trying to prove, I guess, is that he went up to like 23,000 feet, 24,000 feet, something like that. As the air gets really thin, it gets really difficult to breathe. At 6,000 feet, it's not really all that difficult to breathe. So Blaine was going to another level, but I just wonder if this is a copycat of what he was doing. It's starting to feel like that.
So Boeing is considering selling their commercial headquarters. Alan, have you been to their Seattle headquarters?
Yes, I have a couple of different times. It's a really interesting building. It's a very modern building, and it's one of the as you drive through the Boeing complex, it's one of the buildings that stands out to you. So it housed the Boeing hierarchy for a long time until they all moved to Chicago to make their new headquarters. And I still don't really understand the whole Chicago move. I guess it was just to say, hey, we're an international company and we're not just a Seattle company. Okay, whatever. But at some point, when that headquarters did really move, there was a big concern about whether Seattle was going to continue to be the landmark location for Boeing in terms of aircraft production. And now with the South Carolina 787 manufacturing just going to occur down in South Carolina, and they're going to stop all production up in the Seattle area, and they want to sell off the old headquarters building, it's starting to feel a little ominous. I'm sure with the 737 pressure, with COVID-19 and not a lot of people flying, and now the sort of realignment of Boeing, and the stock prices hasn't been doing all that great. There's got to be a ton of concern from the employees and the surrounding community is how long is Boeing planning on staying, and what are we doing and from a state government, local government thing. I know that they've given Boeing a number of tax incentives to hang around the area, but I'm not sure that's working anymore. It's just not what you want to see, because this goes back to our discussion a couple of episodes ago about the eVTOL market and how the eVTOL market is occurring in Silicon Valley and Europe and Vermont, but it's not happening in normally located aerospace centers like Seattle or Wichita or even Oklahoma City or some parts of North Carolina or even some of the Florida things. Like there's some sort of weird realignment going on in the aerospace industry, and Boeing is too large of a company to make drastic changes quickly, but we're seeing relatively massive reorganizational changes in geography where aerospace occurs. Obviously, during World War II, there was a lot of manufacturing, and after World War II, there was a lot of manufacturing in California for aircraft production, pre-war, post-war. But boy, oh boy, you just start to wonder how long Boeing's going to be really tied to the Seattle area, because it would be a real shame. There's just so much talent and skill in that area that has developed over such a long period of time that pulling out of there on any scale, it's got to be painful.
Yeah, and when you wonder if this is the time to really sell, because I still think that, and this is just my personal opinion, that people are going to really long to get back around other people, and the quality of work that you do, depending on obviously what your job is, but there's still just a big need for collaboration and just being able to be at the desk next to someone and say, let me scribble on this piece of paper. Like, what do you think of this idea? What do you think of this concept? I mean, it's just not well done over Zoom, right? And I think given the opportunity in 6 months or a year, if people say, hey, can we come back in like little pods, or can we just have our unit of Boeing or our unit of, company X, can we have a space in a WeWork over here, or a co-working space over there, or can it be kind of back to work, but maybe not in a massive corporate campus? You never know. I'm not sure, but I think it's, and of course, I'm certainly not a CEO of a massive company. Like, they have a lot to think about, obviously, but you just wonder if this is the right time to be selling off, and because they might want their campus back in 2 years. That's kind of where I feel like everyone should just come back.
They're kind of landlocked. It's not Kansas where you've got thousands and thousands of acres. You can just plant yourself somewhere else. Seattle is not that way. There's limited places where you want to build an airplane factory. So you really don't want to give up something on prime real estate, which you own. You just want to if you just want to close the doors and call it a day, or lease it with a contingency. We can kick you out in 60 days. Maybe that makes a little more sense, but I'm not sure selling it makes any real sense right now.
All right, so moving on to our engineering segment, Alan, let's talk about the barn owl. So, interesting article from General Aviation News that, they're studying the way, and like, everyone loves owls. They're super cool looking. They're vicious. They also look calm because they fly just so gracefully. But obviously, like we've talked about trailing edge serrations on our other podcasts about wind energy, how that technology is coming to wind turbine blades, how the chevrons, which is essentially the same thing, are on jet engines to reduce noise. So lots of lessons learned from different creatures like the barn owl.
Right.
But so in this study, or this article, they had an owl named Lily in the lab at the Royal Veterinary College, and they're just tracking motion, kind of challenging her with different gusts of wind to see how she reacts and when she starts to become aerodynamically unsettled or unstable. So what are aircraft engineers learning from stuff like this?
Well, I think they've already incorporated some of that technology of being able to adjust to varying wind conditions, turbulence. I think the 787 has done that, and maybe an Airbus airplane has done that. Because if you think of let's just give the comparison here, because I'll show the example as we get to owls. So an old 737 wing, or even a Learjet wing, pretty stiff wing. Right, it's a pretty stiff thing, not a lot of flexing. Till you get to the 787, and it looks like bird wings, and those wings are flexing a whole lot. In fact, the wingtip seems to be above the edge, the top of the fuselage. When you look way out there, it starts to scream like, "Oh, wow, that looks like a bird." I mean, it's got that sort of flappy thing going on out there. As you make the wings long and efficient, you start to resemble more and more of a bird type wing. But I thought that Honeywell, and I could correct me if I'm wrong, but I think that Honeywell had done some advanced technology where they're using the radar systems. Maybe it was Rockwell was using radar systems to see wind shear and things ahead of the airplane, and then to use the flight control system to dampen the effects and the loading on the wings and on the cabin, so you're not shaking around and people are throwing up and the whole thing knocking over your coffee. But the owl is a really interesting design in terms of how smoothly it flies, and also because its head relatively doesn't move. Like it does everything about itself to keep its head very steady so it can track.
I gotta jump in and comment and laugh at you saying the owl has an interesting design. Like, good job, God.
It does.
Way to go. Like, you crushed it. You crushed it with the owl.
Yay, God, right?
Yeah. Anyway,
he doesn't need my approval, but it is a really cool design, and we've because we live in the wilderness, we do see owls traipsing around once in a while out back, and if you watch them, it's almost eerie to watch them move, and it goes back to a book that I think you recommended to me, or somebody recommended, called Habit, which is the way your brain processes information, the things that are repeating. And the owl reacts so naturally to wind gusts and wind changes, like they immediately know what to do. It's just instinctual almost, because it's built into probably the root part of their brain, where habit occurs when I feel this kind of wind gust, I know immediately how to move, and I can take care of it. Whereas a computer system doesn't work that way. Right? It doesn't have that sort of core logic of it's reacting like an animal and then instinctually like that. But we're getting closer. We're getting closer. I'm not saying we're not there yet, but we're getting a lot closer than we were 10 years ago. But it's funny how we still garner so much information from nature on how it works. It's just like today, learning about the quote unquote plastics that are generated by sea microbes that absorb carbon dioxide and make a plastic. You're like, wow, that's holy cow, that's really cool, right? So you have a microbe that's generating plastic that's then breaks down in the sun, so there's like no impact, and you're like, man, there's so much we're learning from nature about how things fly, about how things develop, and we're just like barely skimming the surface. So when we do some really interesting research, it's just fascinating, and the way the cameras are now, we can just see things we couldn't have seen before, and it just blows my mind a lot of times. It's cool.
Yeah. Well, speaking of your mind being blown, this Albatross 1 project from Airbus is really cool. So this is a demonstrator. It's small scale, obviously. Looks like it's maybe like 6 feet tip to tip. Don't quote me on that, but it's got what would you call these in the wings? Is it segmented, or what is there a term for it? But looks like it's broken into 3 sections, and they can sort of flap, right?
Yeah, the wingtips can move independently. They're not fixed like they would be in any wing structure that I've ever flown in. The tips are sort of elastically connected, it looked like. It wasn't like they were free to do whatever they wanted to, but they could kind of respond to the way that the airflow was coming. And the reason why Airbus was playing with this is that they realized it reduced drag and reduced wing loading, which thereby extends the lifetime of the wings and makes the airplanes more efficient. And like I've said on many occasions on this podcast, they did a model of it, and they were flying it to prove out the technology on the smallest scales they could. It was the video. Did you watch the video of that where they had
it's really interesting.
Airplane sliced in half and stuck to the side of a panel van, and they're driving down the runway, watching how this wing responds in sort of this cheap and dirty wind tunnel. I mean, that's essentially what it was, is the cheapest wind tunnel you can get, which is driving down a runway at speed. So they were actually getting data and proving out the concept at a low level, then to see if there's some technology, knowledge base, ability to extrapolate it to something that's larger. You're not going to see this on your local A320 in the next 5 years. That's non-starter. But you may see it on other types of airplanes like these eVTOLs. That's where I think this is going, that if you can reduce the amount of drag on a smaller aircraft, thereby increasing its range, you're going to do it. And on a small scale, it makes a lot of sense to take some of this technology. So even though the aircraft model they were using was essentially an Airbus A320 type airplane, I don't think that's where they're going with this. I think they're looking at smaller scale sort of things and aircraft designs to implement this technology to improve efficiency, which would be super cool.
Yeah, well, I think the one thing the eVTOLs definitely need more of is complexity to their designs to really, push them into certification. Maybe get the first one certified in like 2050 by the time, I'm an old man. And yeah, but no, you're right. It's certainly going to have to start small scale first, but
right,
those poor eVTOLs keep adding complexity. They're never going to get there. We're never going to have
about
flying
energy.
taxis.
It's all
Yeah,
about
I just
energy.
want to go get ice cream in a flying taxi. All right, don't complicate my dreams here. So,
It's
but no,
gonna
that's
be a while.
it's a super cool demonstrator, and watching the video is really impressive. So we'll put the links to it in the show notes. But like we talked about before, it seems like you do need big companies like Airbus and Boeing to try and use stuff like this out, knowing that it's obviously not going to make them any money, and might be a miserable failure, but it just continues to push, aerospace engineering just a little bit further, right?
Right. Oh yeah.
All right, so let's jump into our electric segment today. So first thing on the docket, we're going to talk about drone testing at the FedEx hub in Memphis. So I think this makes a lot of sense. Obviously, there's challenges with drones flying around, and commercial drones that can carry a little payload and do a lot of those things, not just like a little hobbyist one the size of your cell phone, but these are big drones with like a potentially 6 foot circumference, sometimes bigger. So they could cause some damage running into things, right? So there's obviously a lot of precautions here, but FedEx is testing them, transporting tools to the other side of the airport, or transporting a part, or whatever it is, surveying, weather conditions on a runway, or, surveying birds. Or are there birds down at this section of the tarmac? So obviously you've spent your life in aviation. How does this idea strike you?
I think it's totally awesome. I when I saw the FedEx video, I was surprised that FedEx actually put up a video of it, because they usually put up videos that have more to do with the package delivery than it does the sort of the machinations of how they get their airplanes up in the air. But they were really working with the FAA to demonstrate that they could do drones safely in and around aircraft airspace, and where aircraft are moving around. And FedEx is always very forward thinking, and they're also extremely safety conscious. They do things that airlines do not do, and they're still moving packages. So they have a lot of advanced capabilities and technology in the cockpits and in the aircraft, because they travel to so many different remote locations. They just need that little bit of an advantage of having the pilots have the most information they possibly can, and having the best operating airplanes they could possibly have also, because they got to move traffic all the time. So downtime is a killer for FedEx. Now, the first thing that came to me was just aircraft inspection. That if you had an aircraft, how fast could a drone possibly inspect an airplane? Probably 15, 20 minutes, right? As kind of a walk around. And these airplanes are huge, like a 777 DC-10 airplane. Those airplanes are huge. It's very hard to do a real walk around them. You could have a drone really scan the surface of the aircraft and say, yeah, hey, everything's all there. All your pieces are there. Nothing's falling off. Everything's A-okay for the next flight. There's no dents or dings or missing components, that kind of thing. Or to detect it and get it repaired as fast as you can. I think that's where the drone technology lies. And obviously they can carry packages, equipment from one part of the airport to the other. Remember that Memphis is it is the FedEx hub in the United States. And then they do have other places that do package movement, but that's the big one. And if you left your box of wrenches down at airplane A, it may be a long walk or a 10-minute ride down to go get it to come back. And it just, hey, Joe, can you throw them in the drone and send it this way? Sure, boom. And it just saves time. So on the time-saving side, huge. On the safety side, huge. On just aircraft inspection, I think that's where we're going, is really, really good. And, hats off to FedEx for publicizing it, because it seems like they're trying to work with the FAA and be upfront and get the technology developed in a partnership with the FAA, instead of trying to just cold cock the FAA with it, which is never a good idea. So, hats off to FedEx. And if you have a chance, check out that video on YouTube. It's really slick.
Yeah, absolutely. And it does, obviously, even with like the commercial drones, like I have a little DJI drone, and they can limit height, right? They can pre-program en route. So like mine, when it runs low on battery, it will just return to home. So if it's down to 15%, like it's coming back, and it just knows where to go with GPS. So I'm sure they could pre-program in all these different flight routes, where one drone is just like, hey, like you said, hey, Joe, can you send me this? Boom, he hits a button, and it's just going to take its pre-programmed safe route, not in any, couldn't possibly be in a real aircraft's way, right. It just flies over. So you hit me to send the drone to location F, pushes a button, off it goes. Like that's clearly within the technology's limits right now, and obviously take it way beyond that as it goes. So I'm sure it's just going to have to be worked out, but definitely seems like a viable technology. So last thing on our list today, the Ampaire EEL, which is a 6-seat Cessna 337, and this is modified. It's twin-engine prop plane with an electric motor. So this is what they're claiming is, pretty much the most commercially relevant aircraft right now that's all electric. Recently, they they landed at Hayward Executive Airport, flying from California's Central Valley. So they took off from Camarillo Airport and landed at Hayward. So about 292 statute miles. So, Alan, how significant is this little flight?
I think it's huge. I mean, we had a discussion last week about the Casio being a hybrid. This is exactly the same type of approach, which is a hybrid. It's a Skymaster 337, so it's got propeller in the front, propeller in the back, and they've taken the internal combustion engine out of the front end of this thing and put in an electric motor and a propeller, and the internal combustion engine on the back end is still there. But I think the application is really interesting in that they're going to basically take this whole thing to Hawaii and test flight it just to jump between the islands. So shuttle people back and forth between the islands, which would typically be a larger airplane, a more commercial flight, or a helicopter flight, or a boat. Which obviously uses fuels. This is going to use electricity to do that. That's really fascinating because it's found a technology. It's found a place for the technology and a place where they can develop the technology, which is exactly how you get a technology into service. Is you got to find the right application. You got to create a product with it. So the electric motor propeller design is something that can be done, but can you find a market in which you can service it? George Bai's done it, and Bai Aerospace is doing it on the trainer side. Ampaire's doing it on the short hop flight, island to island, sort of short commuter service aspect. Those are brilliant ideas, and that's the way you prove these things out and build confidence in the electric propulsion systems, is by starting off small, getting it working, gradually building it over time, so you build confidence in it because you have people in these things. And as you build confidence, you learn from your mistakes and the difficulties with it. You correct those situations, or you engineer through them, and you get better and better and better and better and better. That's what should be happening. And hats off to these guys that are doing this. It's just amazing stuff.
All right, well, that'll do it for today's episode of Struck. If you're new to the show, thank you so much for listening, and please leave a review and subscribe on iTunes, Spotify, or wherever you listen to podcasts. Check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from the show. And follow us on LinkedIn, Twitter, Instagram, and Facebook. Our handle is @WGLightning. Tune in next Tuesday for another great episode on aviation, aerospace engineering, and lightning protection.